This video clip is part of the EPFL introductory course on information computing and communication. It is the first one on information storage and management. It starts with a brief reminder on storage technologies and then explains the basic principle behind storage organization and management. The previous set of video clips of this ICC course introduced the same table as seen on this slide, which shows the relative latency, throughput, cost, unit size, and other properties of different memory and storage technologies. The present set of video clips focuses on managing information residing in the lower three types of storage devices in this table. Flash storage devices, such as USB sticks and SD mini cards, provide random access like cache or main memory, but they're accessed like hard disks in chunks of several kilobytes called pages. The same is true for hard disks, although they suffer from substantially higher latency because accessing any given page record on disk requires waiting for the disk arm to move over the right track and then the disk to rotate until the right record is under the reading arm. Magnetic tapes, of course, need to unwind on one side and rewind on the other, thus allowing access to information in a strictly sequential way and with the latency increasing as the tape rolls. One very important issue in storage management is how structured the stored data are. The more, the easier they are to manage. Unstructured data are data such as a mixed sequence of numbers, characters, graphics, images, photos, audios, and/or video clips that do not present any internal structure allowing direct access to any specific element in the sequence, such as, for instance, a specific number, word, paragraph, chapter, picture, audio, or video section. Storing such data sequences is easy. One can just accumulate them one after the other in storage. Retrieving them, exploring them, and interpreting them is, however, enormously difficult because their lack of internal structure does not allow accessing them other than sequentially, as if they were stored one after the other on a tape. By contrast, structured data do present an explicit internal structure that facilitates direct access to any of their internal components. Such data are harder to store and manage because one needs to preserve and maintain their internal structure. They are, however, much easier to access, explore, and interpret because that internal structure allows direct access to all internal elements. Most of the information generated and stored in cyberspace is unstructured, and simplifying access to them is the raison d'être of search engines like Google, which spend all their time frantically and endlessly crawling the web to index it and make information retrieval easier. In spite of all such efforts, retrieving and exploring unstructured documents is never as easy as doing the same on structured documents. Trying to find information about a statistics professor called Michael Jordan on Google is impossible because he's of course totally overshadowed by his namesake basketball star and will not even show up in the top 10 Google responses. Even if one adds the keyword statistics to the search, the top 10 Google results will be on the basketball star statistics. By contrast, finding information on this professor in the structured databases of any of the many organizations that he's involved in is trivial. We now come to the basic challenge of structuring data. Imagine a hard disk without any internal structure. First of all, how can one know whether this disk contains any information at all? Maybe the bits are just random magnetic noise. Assuming the disk does contain real information, trying to find any specific piece of information on it is like looking for a needle in a haystack, looking for a song in a music library without a catalog, looking for the works of a composer in a library classified by interpreters, looking for the words of an unidentified interpreter about which one only knows the title of one song. or looking for a song of which one only knows a few words and notes, but neither the title nor the author. To do any better, even Google needs structure, and indeed creates some by indexing the web in a way that we will see later in this set of clips. In the simpler case of just one disk, structure its data works as follows. On the disk, one reserves a specific fraction of the space at a specific and fixed place to store all the structuring information. This structuring information consists of so-called metadata catalogs or directories describing what and where is the actual data on the rest of the disk.